morning friends. Now we are going to see about the topic turbines and pumps. So when we classify all the machines, we will be classifying it into first energy consuming devices and second the energy producing devices. So energy consuming devices consumes the energy and produces the mechanical output or useful power. Example, a pump will absorb the electrical energy and converts the electrical energy into mechanical energy, and which will be transmitted to the water, so the water can be raised from a lower level to the high ground. And this very similar vice versa will be obtained in a turbine. Turbine will be absorbing the energy from the water and producing the mechanical work. So when we classify the turbine, the energy flow will be in the direction of water to the shaft. So we can see the impeller. The impeller will be doing the work of transferring the energy from water to the impeller, or either to the impeller to the shaft. For a pump and turbine, the energy flow will be showing here. So we have a very different variety of turbines. So when we go for turbines with the commonly used of impulse and reaction type, the impulse one will have the Francis Pelton wheel turbine, and the reaction will have the Francis and Kaplan turbine. These turbines will be selected based on the head which is available. So head, what do you mean refers to the head is it is the vertical distance the water can be raised from the ground level based on the energy available with the water. So if you have a high head fluid, say it has a head of 50 meter, then the water will, and if you take in a small narrow tube of 1 centimeter diameter, and if the water will be rising to the height of 50 meter due to the energy which is present in the water due to the flow. So based on that, the energy will be obtained. So while selecting this, the head is playing a very major role, because when we go for a power generated by the water, we will get the equation like rho g h into q. Rho is density of water, g is acceleration due to gravity, and h is head of the water, and q is discharge or volumetric flow of water. So based on this, we can observe that the head and discharge are the two variable factors in the power input or energy inside the water. When we go for the other terms, so rho and acceleration due to gravity, they are almost constant. But if we want to have a uniform power, either you can increase a h and decrease a q value, or if you can keep it as a constant ratio. So based on this, by altering this, we can you can be able to get a same power itself. Okay, thank you. We will continue with the various parts which is available in the turbine. So the turbine has to be made of several components. With that alone, it will be operating. The first component is penstock. So we are saying that the turbine is running on water. So water has to come in through a device, to a pipeline. That pipeline system is called as a penstock, and it also has to leave out, and that for arrangement is called as a draft tube. And we have the runners, which is a rotating component in which the impellers will be attached, and then the output shaft. So the runners will be attached to the output shaft, by that shaft will be delivering the power output. And then the casing. The casing is the structural enclosure of the turbine. The casing will be playing a major role in reaction turbines and a minor role in impulse turbines. So for a Pelton wheel turbine, which is an impulse turbine, the bucket arrangement will be present in the runner. That bucket arrangement will act as a impeller, and the braking jet is also required for impulse turbine, because the impulse turbine will have high inertia force which needs to be stopped only by any extra arrangement, which is a braking jet we will be providing. And the nozzle and spear arrangement is also available in the Pelton wheel turbine, because the nozzle arrangement is not there. The nozzle consider we are using electricity in a home. So this electricity is produced by a turbine in a power station. So when you are considering the speed of a turbine in the power station, that is to be a very critical one in the frequency of electric current, because normally in India we are using only 230 volt DC, AC current with 50 hertz frequency. So when the frequency is getting altered, that will damage our all equipments. Okay, so in that case, if RPM increased by 10, so if instead of running at 1500 RPM exactly, if the RPM increased to 1510, then automatically our the equipment starts to get damaged. So in this regard, we should control the RPM. That control will be provided by the sphere arrangement, where the nozzle is used for the velocity increase. So I have told you earlier that a casing is going to play a major role in a reaction turbine, because the water has to be supplied continuously in the reaction turbine through the casing alone. The casing alone will provide the pressure, will be acting as a pressure medium vessel. If the vessel is leaked, the water won't be stored inside. So when the water is not flowing and the leak is there, we will have a very big loss. So, but in Pelton wheel, the casing is just to provide a safety that splashing out water should not hit any person. But in reaction turbine, the casing will be acting as a guiding part. The water will, and it will be guiding the water in which direction to flow, and all this will be done with using the casing. And the guiding mechanism is used to direct the water into the impeller. We said the impeller is a very good, the power producing a working mechanism in the turbine. So guiding mechanism will help the water to be supplied at an optimum angle, so that the work efficiency will be very high. I have learned that